Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future today. Let me start with something that probably feels familiar. Your LLM agent sounds smart, confident, very convincing. And then, halfway through a task, it casually breaks a rule you were very clear about. You see this in scheduling, resource allocation, multi step workflows. The model walks you through its thinking. Everything sounds reasonable, and then it forgets earlier state, violates a constraint, or invents an action that was never allowed. Chain of thought and react help a bit, but the problem keeps showing up. Here's the core insight from this paper. Most of these failures aren't really about reasoning, they're about representation. The model is reasoning correctly, but over an implicit, unstable mental model of the task. And no amount of step by step thinking can rescue a bad or missing model. Think about how humans approach problems. Engineers define systems before optimizing them. Scientists define variables before drawing conclusions. Classical AI planners define actions and constraints before searching for a plan. Reasoning doesn't magically create structure, it operates on structure. LLMs usually skip that setup step entirely. That's where model first reasoning comes in. The idea is almost boringly simple, but it works. Before solving anything, the model has to explicitly build a problem model. It lists the entities, defines state variables that can change, spells out allowed actions with their preconditions and effects, and clearly states constraints that must never be violated. And this part matters. There is no solution yet, no planning, no reasoning ahead. Just the model that forces the LLM to commit to a clear, inspectable view of what the problem actually is. Only after that does reasoning begin. And now there's a rule. All reasoning has to stay inside the model. Actions must meet preconditions. State transitions must match defined effects. Constraints have to hold at every step. At that point, planning feels very different. It's model based inference, not freeform text generation. Mistakes become visible. Violations are easier to spot, and long horizon consistency improves a lot. What's nice is how practical this is. No new architecture, no fine tuning, no symbolic solver hiding in the background. It's all prompt based. One thing to watch out for though, if the initial model is incomplete, everything downstream falls apart. Practical tip: force the agent to restate all constraints. Before it's allowed to plan, get the model right first, and the reasoning usually behaves. If you found this helpful, hit like, subscribe, and comment which agent system you want to build next. See you in the next video.